Now you should be in your notes. Find the chart that says comparing measures of center and spread. And we're going to do some comparisons of the median and the mean and give you some examples, and hopefully this will clear up some of the concepts. First of all, what does it measure and how do you find it? The median balances counts and the mean balances deviations. Now what exactly does that mean? I'm going to give you an example. Let's say we have a very small data set, the numbers 1, 3, and 8. The median, or the middle number, is 3. It balances counts. Half of the counts of data are on one side of the median and half of the counts of data are on the other side. In other words, there's an equal number of data values on either side of the median. The mean is 4. The mean balances deviations. A deviation is how much a data value differs from the mean. So, for example, get a pen here. 1 is 3 less than the mean. 3 is 1 less than the mean. And 8 is 4 more than the mean. If we add these three numbers together, I'm doing this with my mouse so it's kind of slow. If we add together these numbers, they equal 0. So this is always true for the mean. If we take the mean and we add up the differences of all the data values from the mean, add them up, we always end up with 0. Now, as far as finding the mean, not hard. If you, for the median, if you arrange the data from smallest to largest, it's the middle number, or in the case where there is an even number of data values, it's the average of the two middle numbers. For the mean, you add up all the data values and divide by the number of data values. This is actually an AP formula. X bar represents the mean of a sample. Just a note, your book uses Y bar, but the AP formula sheet uses X bar, and so I'm going to always use the formula in the way that you'll see it on the AP book, or the AP formula sheet. The book, our author has this funny reason that he likes using Y instead of X, but I don't really agree with it, so I'm not going to use his notation. This stands for the sum of X sub I, so that would, I represents just all the different data values like X sub 1, X sub 2, X sub 3, and so forth. You add up all those data values and divide by N, which is the number of data values. Pretty easy form. You know how to do this, but just to show you what this formula means. For what types of distributions can you use the median and the mean? The median can be used for any distribution, but it's particularly useful when summarizing skewed data. And a good example is when you're talking about median home values in an area. Maybe you have a lot of homes of certain values, but you always have those few really, really expensive homes, like some mansion that's worth $5 million or something. And if you took the average home price in an area, it would be not reflective of the typical home price, because that one really high priced home makes all of the average seems higher than it should be. So that's when a median is particularly useful. The mean is a useful measure only when the distribution of data is fairly symmetric. Otherwise, the mean doesn't represent the true middle. How are the mean and median affected by outliers? The mean is resistant to outliers, meaning that outliers have very little effect, if any, on the median. As a matter of fact, the only time they do have an effect on the median is if you end up having to average in a value, or you add a value and it just shifts the median. Instead of being the middle number, maybe it becomes the average of two middle numbers because you've tacked on an extra piece of data. But it's very, very little effect generally. The mean is sensitive to outliers, meaning that it is greatly affected by outliers. Just as an example here, let's take our simple little data set, but let's say we change the numbers instead of 1, 3, and 8 to 1, 3, and 20. Well, the median is still the same. It's the middle number. The mean, however, now is the average of 24, a sum of 24, so it's 8. How are the mean and the median related to the histogram? The median divides the area of the histogram in half, whereas the mean is the balancing point of the histogram. And I think it would be useful, helpful if I showed you an example of that. So let's say we have a very symmetric distribution of data represented by these squares. The median is the middle value, divides the area in half. So half of the area of the histograms on this side, half's on this side. The mean is the balancing point. You can tell just by looking that that would balance because there's exactly the same amount of blocks on both sides and they're in the same positions. Now, let's say I have the same number of blocks on both sides. I still have 6 blocks on both sides, but now I've arranged them like this. Well, just common sense tells you that if I left the mean where it was, the data value would start to tip this direction. Because I move these blocks way out to the edge, they have more leverage out here. So in order to balance the histogram, I would have to shift the mean to the left. In other words, the mean will move in the direction of the outliers, whereas the median stays the same. What is the related measure of spread in its formula? For the median, whenever we talk about the median, its related measure of spread is the IQR. And when we talk about box plots, and I can't remember now at this point if you've talked about them or not already. I think you maybe have. But the interquartile range measures the middle 50% of the data, the difference between the Q3 and Q1, which are values that basically the median is like Q2. It divides the data in half, and so Q1 divides the first half of the data in half, and Q3 divides the second half of the data in half. So they mark like the 25th percentile and the 75th percentile. So that's the middle 50% of the data. So we use that to measure spread for the median. The mean is measured by what's called the standard deviation. This is the formula for standard deviation, and we're going to spend some time talking about that in class, so I'm not going to give you any more information about that. I actually wrote the wrong thing here. We really should call that S. Sigma is the standard deviation of an entire population of data, but we're talking about a sample of data, so change that to S rather than and cross out the word sigma. Maybe I'll just cross this all out right now for you. Okay, there is the information you need about median and mean.